So this session will be about closed loop automation and primarily focusing on the two aspects of it called the auto scaling and alerting. So, what we support in the current closed loop automation strategy around auto scaling alarming. So we'll cover that as the first thing, and then maybe we'll go into um, more interesting things like what is coming in the future release, in release 10, and so on. Okay, so I'm revisiting what Atul was presenting. What are the different modules of service assurance? I think, and the most important modules that we have in service assurance is MON and POL. The MON is for the monitoring aspect, the POL is for the policy management, and then we have several other modules that Atul just has touched upon, so I will not go through in details of that. I will be focusing mostly on this MON and POL right now, which are the important module for the closed loop operation and bringing in automation in the network in case of there is a failure that has happened, or there is an issue that is been discovered in the network. So before going further into what is closed loop, what are the different features of the closed loop automation, let us spend some time in what closed loop operation itself. So closed loop operation stands on these three different pillars: observe, decide, and act. And the reason of closed loop operation is to automate the entire the network procedures. That means it is not only about onboarding of the network services, it's also managing the life cycle of the network service in a complete automated way. That means I observe how my network services are performing, then decide whether it is in a good health or there is some problem in that network service and I have to do something else. For example, say I may have to scale out this service because there's extra traffic that is coming in, or maybe I have to scale out because the current network service is not able to take the traffic that is coming in right now and is able to cater to all my users. And then after you decide what has to be done, the third is the act part of it. The act part is about taking the action on ground, telling the orchestrator that either to scale out or send an alarm and so on. And then you take a feedback to improve as well. That means you have taken an action and you want to do something better next time. So you observe it again and decide like whether what I have done, I've scaled out, is that enough, or I have to scale down more, and then act. Okay, so with that, um, what are the most important features in the closed loop operation today? So there are two important features. One is the auto scaling. The auto scaling is about whenever the VNF discovers that there is a threshold that has breached. The threshold can be set on different matrices that it is collecting. For example, it can set on CPU. If the CPU load is going high and crosses a certain threshold, it will scale out by adding more videos to this. And how much it will scale out, at what condition it will scale out, we'll see in the later slide. But the most important thing is there is a rule that tells that what to monitor, what to do, when to decide that I have to scale out, and then you go ahead and scale out when that condition is met. Similarly, there is a scale down or scale in operation as well. In the scale in operation, when it again reaches a normal condition, that means the alarming condition has gone and the service has restored to normal. That means the CPU load has come down. Then maybe you will like to scale down the network. And this can be done both for the Vim matrices and the VNF matrices as well. Okay, so that is the scaling procedure. That means how you scale out a VNF or scale in a VNF. Then the next is the alarm. That means rather than you taking a decision as an orchestrator, you want the service assurance or the OSS, which is say outside the OSM, and it is say part of the service assurance infrastructure of the service provider, and you want to just send an alert that okay, there is an alarming condition that has happened, but I am not going to take an action. You decide what to do. So when you want to alert an external entity, that is where you send an alarm or an alert to an external entity through webhooks. So these two things, like what happens in auto scaling and alarms as part of the closed loop. So so we'll see more about this in the coming slide. So, but before that, let me again revisit the MON and a new architecture called POL. So you can find more information here in this link. For MON, the architecture, Atul has already gone through this architecture. But what is most important part of it for the closed loop is the MON evaluator. So what happens? Let me revisit one more time. That whenever there is a new alarm that is configured as a rule, then the MON server goes and puts it in the common DB. The MON evaluator continuously evaluates this rule, and based on the matrices that are collected and stored in Prometheus, it decides whether the alarming condition has happened or not, and then it will take an action for the alarm. And the MON collector is about like the collecting and keeping. So the MON collector is the basic collectors. But what is more important is the evaluation part here. That means it evaluates the rules continuously and decides when an alarming condition has happened, and I have to take an action corresponding to that alarm. Now there is another module called POL, which takes these information from MON, that when the MON has evaluated that there is a problem that has happened, it takes this information and then it goes and takes the action by itself. And how it does, it will be clear in the next slide. Okay, so this looks a bit busy slide, but I think it is not very difficult to understand. What we have seen in the previous slide, we just connected all the dots together here. Excuse me. So the first module is the MON evaluator. What it does is it takes the alarm information or the rules that are there, like if this is my threshold and if it crosses the threshold, this kind of action I have to take. So this is a rule. That the rule information is taken by the MON evaluator, and then it queries the time series database, which is Prometheus in this case, to understand what is the current situation of the matrix. Has it crossed the threshold or not? So with the rule and the current status, it decides whether there is an alarming condition that has happened. And if the alarming condition has happened, it then tells Paul that, okay, the alarm has happened and you have to take an action. Then Paul goes and finds out like what action I have to take. It, as we saw in the last slide, it can have two actions. Either it has been asked to scale out the network service and VNF infrastructure. So it will go and invoke the lifecycle manager by telling it that, hey, scale out this VNF and increase the number of videos to say 2 or 3, depending on what is there in the rule. Or if it is an alert, then it will not go to the LCM. LCM is part of the OSM, so it is going inside OSM for scaling out. But if it is alerting, it has to go out of OSM, and then a webhook has to be called, and this webhook will be say a some location in the external OSS of the service provider, or it can be some alarm system that is external to OSM. So anything that is external and which can be only invoked through a webhook through an HTTP request, that will be through the alarming system. So either I'm taking action myself as OSM by sending it to LCM, or I feel that I cannot take an action and I have to inform an external entity for it to take a action at a broader level. That will happen through the webhook. So there is something that is coming up and is in the plan, is that can these alarms be also obtained from the common DB? So there is no way today in OSM to see whether the alarms are, what are the alarms that have been configured, and how I can, or what are the action that has to be taken for this alarm. So and we are enriching the northbound interface so that these alarms can be queried, and maybe it also can be viewed in the NGUI that you are using as part of OSM. Okay, so how we define this? So for defining the scaling policies or the alerting policies, we have to define it in the VNF descriptor of that particular VNF. For example, say in the Magma VNF, you will define a new scaling criteria policy and a scaling criteria, in which you will define few things like the scale out relation, like what is the scale out policy, what is the threshold. That I am saying that if the threshold is 60 for my CPU, and if it crosses 60, then maybe for that particular VNF, then maybe I should scale out. Okay, and if it goes beyond or it is less than 10 in the threshold, maybe I will scale down. So the scaling policy and the scaling criteria in specific tells me that what is the scaling rule that I have created. One is that it is greater than 60, then it will scale out for this particular metric, that is CPU here, or scale in if it is less than 10. And the threshold time for which I have to watch before I scale out is 10. Okay, and the video that I have to use is the Magma video. So this is how you define in the scaling group descriptor using the scaling policy and the scaling criteria. What is the rule that I have to use, what is the threshold I have to use, and how much I should scale out. That's, for example, here I'm saying scale out by 1 to scale out the network service. Similarly, there is an alarm as well. That means if, say, I have to alert an external system, I can define an webhook inside my alarm system as well. Okay, so let's see how it looks like in my network itself. Just a minute. Okay. So this is my OSM MANO. So if you open the AGW network service descriptor in your network slice, okay, and this is your VNF descriptor of this AGW VNF. And if I come down, and just a second, not this one. I mean 8, and this is, it will be just a second. here I have to go to the VNF descriptor and here. Okay, this is the one. So I have to go to the VNF package in the VNF descriptor, and if I come down, so you'll see in say row number 127, you have the alarms described here. That is the webhook described, and what is the metrics that I have, or what is the alarm ID, and when I have to scale out. So when it is greater than 80, I'm scaling out. And if I come down, here you will see that the scaling group is described here. So this is like the monitoring parameters. What are the parameters that I have to monitor? And below this, you have the scaling descriptor also. That means when I have to actually scale out. For example, the scaling policy name is CPU utilization, and then I use the threshold, or I set up the threshold here, that is when it's greater than 60 for this this parameter VNF monitoring param, and then I am able to scale it out. So in the VNF descriptor itself, you can define the scaling group as you have seen here, or you can also define the alarms. Just a second. The alarms in the VNF descriptor to define this. Okay. So any questions up to this point? Okay. If there's no question, let me move forward. So what are the new things that is coming in? So what you have seen till now, I'm again revisiting the closed loop automation. So what you have seen till now is the reactive closed loop automation. That means when I'm seeing something going wrong and it crosses a threshold, I take an action. That is also good, because when the system or the orchestration system finds out what is the problem, it will be faster than human to fix it before the human is able to detect the problem and start complaining. That means as an end user, I will start complaining when it deteriorates at my end. So even if it is a reactive closed loop, I detect it faster than the human and take an action. That is good. But in future, we want to go to more proactive closed loop. That means even before the problem has happened, even the matrices are started deteriorating, can I predict in advance whether the matrix will go down and then decide and act? For that, one of the important thing that is coming up in release 10 and release 11 is the machine learning part. We'll talk briefly about that. But the vision here is about to strengthen the observability. So as one of you are mentioning about, can I add more matrices? So we have SNMP, Vim matrices are coming in this new scalable matrix architecture. And there are others like netconf, gRPC that will also come in future. So can I strengthen the observability that we are doing now? Can I strengthen the decision part? That means not being just reactive, I can be proactive. That means I can forecast my matrices, and then based on the forecasted values, can I use a predictive threshold to decide whether I have to act, and act at a more granular level than what we are able to do today. That means, can I not only do auto scale, but also auto healing maybe in a more granular way. Okay, so what are these new features that are coming in? As I mentioned, there's scalable matrix collection. That means we are refactoring MON to add this exporter-based matrix collection mechanism. SNMP exporter is already there. Vim exporter is coming in OpenStack and VMware and so on. It will also help me to fix some of the known bugs today, like the zombie processes we get repeated complaint. Because what happens when mon is overloaded, maybe it starts restarting, and then you have the older process which has not completely ended, creates zombie processes. So this kind of problem can be resolved if we have a more refactored mon which is less loaded. Next is the strengthening of the closed loop automation itself. As I mentioned, auto healing is a new feature that we are trying to introduce, so that not only scale but heal when there's a problem. That means if the VNF or the network services has become completely unresponsive, can I reboot that VNF or reinstall that VNF? That is auto healing. Improved policy management, that means policies that you see today are only in the VNF descriptor. Can this be at a more granular level? That means it can be at the level of network service. Can that be at the level of say user, or can that be level at of a project? So at a different levels, can I apply the policy? And another most interesting thing that is coming up is the AI agent. That is how you apply AI and machine learning to have this new use cases, new way of deciding where the problem is can happen. For example, the predictive threshold. Can I predict what is going to come rather than wait and be more reactive? And similarly, the dynamic threshold. So remove threshold altogether and just have a anomaly detection mechanism to find out where the problems are by learning from the normal behavior in past. And don't create those hardcore threshold like greater than 60 or greater than 80 or less than 10. Don't do that. Okay, so how this new refactored auto scaling will look like? So what you have seen now, that all those metrics evaluation is happening in MON. So we wanted to remove this central entity which is doing everything and make it more scalable, more distributed. So every entity who is responsible for generating alarms will do it by itself, and not one has to do centrally. So the VNF can send their own alarms. They will not have to come to MON for generating alarms. The VNF matrices, which is collecting Prometheus, will generate the alarms through an alert manager in Prometheus, and the Vim alarms will directly come from the Vim alarm management system and not be coming from MON. So MON will not become a single point of failure for evaluation. Every system can generate their own alarm and send it to Paul, and Paul will have a more centralized policies to decide what action to take, whether it is going to LCM or it is going to the webhook. Okay, so this is like about how the new architecture is coming in to make it more scalable. A few other things that will also be interesting, like the threshold, setting threshold on a correlation matrix. That means just not one matrix. We can either set on CPU or memory or one of the VNF matrix, but we are not able to set today a combination of different matrices like CPU plus memory plus some other matrices. Those combinations in an AND operation is not possible. That is something we'll try to do in the coming releases. And also a more dynamic ML based anomaly detection. As I mentioned, the dynamic threshold, that means remove the hardcore threshold values altogether and provide a more dynamic learning based thresholding mechanism. That means if I know this is how a normal behavior happens, then I should learn from that behavior through the machine learning system, and then use that learning to decide whether there's a problem or not. And the human will not have to set the threshold or the network administrator will not have to set the threshold by himself. Okay, so this is about all the things that are happening. Another thing that have already coming in release 9, that is about to be released later this month, is the multi-tenant Grafana. So what is happening today, the Grafana, what you are seeing today is mostly you have one user, that is the admin user. So all the different users you have seen in Hackfest, you have a different username in your OSM, but you have to go to Grafana only using the admin tenant. For example, here I am using the OSM instructor 8, but in Grafana I am only able to log in through admin. So everybody is logging through admin. So the problem what happens here is you see so many dashboard which are not relevant to you, so other users dashboard. So that is something we are trying to remove and create a more multi-tenant architecture, so that you can have your own tenant also in Grafana, so that you will not have to search for your dashboard. You only see your dashboard and not others dashboard. And there is some work on Sol6 integration that is happening that I will not take up right now, but just for information I have put it here. Okay, so there was a hands-on session, but we'll not do the hands-on because of the infrastructure issues. Many of you don't have the network service network slice that has come up, but I will briefly go through what we had planned in the hands-on session. So when the network slice comes up, you have these two network services that you will see in the UI. So one of these VNFs, one of these video in this VNF will add extra load by this command, so that we stress the CPU. Once we stress the CPU, your CPU will go high. So suddenly you will see the CPU going high like this, and then it will cross the threshold that we have set earlier, and then it will scale out, and then you will also see these yellow lines here. You will also see the new video that has come in is also visible. So it is automatically monitoring the new video scaled out, that is scaled out. Okay, and then for the alerts, webhooks will be called, and you can see the webhooks in your post request and also. Okay, so that's it about and then you can scale in as well. Okay, so that's all about the session. If you have any questions, just let me know. Let me also see if there are any questions on the chat. So I have one question, Shak. Are metrics collected only for VNFs? What about PNFs and KNFs? So KNF is something that we have in our roadmap. So, for example, the Kate based the KNFs will be monitored in the future as well. It will be another exporter that will come in and monitor. This is the roadmap, but I am not sure whether it is coming in release 10, maybe in release 11 that will come in. PNFs we don't have any plan to monitor yet, so we don't have in the roadmap because it will be tricky to monitor the PNFs. Any other question anyone has?
Yes, thank you for the excellent presentation. It was indeed very interesting to me to hear it. And you mentioned that machine learning algorithms are planned to be introduced in the context of alarms. I think it was on slide 15 from your presentation. So my question is, who is developing the algorithms themselves, and are they open for, for everyone to contribute to, or is it OSM, it's OSM which is only able to contribute to?
Yeah, first of all, let me clarify. First of all, thanks. This is an excellent question. OSM is open and anybody can come and contribute. I think it is not that only few people can contribute. If you have a new algorithm, if you have a new plan, please join our tech session that happens every Thursday. And you can come and provide your proposal. After TSC, that Technical Steering Committee, approves your proposal, you can go ahead and submit your new feature. So that is how it happens. So we'll welcome you to provide any new algorithm. To answer your first part of your question, what algorithm that we are using right now? I think we are using the standard algorithms that we have. For example, we are primarily using the deep learning because we wanted to create the model, save the model in the model server, or it's called model serving, and then from there we pick it up and use it for the forecasting part of it. So we are using this deep learning algorithms like RNN LSTM. That is, I think, the most used or most popular algorithm for forecasting now. And then for the alarming, also we are using autoencoders. So mostly we are relying on those deep learning algorithms, that because it takes less time to learn, though it is complex to train in the first place, but once it is there, we'll be able to train it. One thing that we have done very interestingly is we have kept the model execution or the inference part inside the OSM scope, but the model training is outside the scope. So if you want to bring a model that is trained outside and not submit the algorithm but just submit your model, that is also a possibility. So if you can bring in a new algorithm so that it can be trained within OSM, that is excellent. But if you want to bring a model and just use your model to get the forecasting done, predictive threshold being determined, that is also possible. So I will say we are just starting. I mean, there's many things to do in this space. We are also trying to figure out in our technical calls what is the right architecture, because this is something not very well defined as part of the NAV MANO specification that is kept open. So it is like bringing in new innovations to make it right. So if you have any suggestions, please give it to us. You can write to the tech email.
Thank you so much for your detailed answer. Thanks a lot.
My pleasure. Any other question? Okay, if there is no more question, then I will maybe stop presenting and hand over to my colleague Lars, who will take the PLA session.
Sorry, one more question regarding after healing timeline. When it be ready? What release? 9, 10?
Okay, so a very basic AI will come in release 10. That is what we are planning. We still don't have the complete architecture approved. Some of our community members are already working on this to have the architecture, but it will have two different modules for sure. One is the AI agent and the AI server. So this as a basic infrastructure will come in release 10 with very simple use cases. And then maybe release 11 onwards, we'll see more interesting use cases coming on top of this. So first, we should have the architecture right. That is what we are trying to do in release 10. So you will see a very basic release coming in release 10, which will be, I think, 3 to 4 months from now. And then in release 11 and onwards, you'll see more interesting use case coming on top of that architecture. Did that answer your question?
Absolutely.
Okay, thank you.